For these problems, it's really important to recognize whether the variable is a ratio or an angle. So taking a look at the first one, A, we have sine of the inverse tan of A, and we have to decide, is a ratio or angle? And since it's inside the inverse tan function, the input of an inverse tan function must be a ratio. And that makes the inverse tan, the value of the inverse tan, an angle. So if I were to draw this into our circle here, the tan ratio is A. So I know that the slope is A over 1. And the angle theta is this angle theta that's in question here. So now I have a picture of I have a picture of theta. And really, what am I being asked? I'm being asked to find the sine ratio of the angle theta. Well, in that case, the sine ratio, I can clearly see it's going to be the opposite, or the vertical, over the hypotenuse, or the radius. So I just need to calculate the radius here, and it's going to be 1 squared plus a squared. And so my ratio ends up being a over 1 plus a squared. Now, I've kind of arbitrarily drawn this ratio in quadrant 1. Technically, we could have done this same problem in quadrant 4, but the results would still be the same because a would then be negative, okay, when we just draw the a in the negative direction, but we still would use the same radius. And so we still get a over square root 1 plus a squared. So we just make it easier on ourselves by drawing it in quadrant 1 when possible. For B's quite a bit harder, and that's why the little star is there. So not too many people are going to kind of be able to work this out, but we'll take a shot at it. So again, the first thing we want to think of is the negative x an angle or is it a ratio? So sine negative x, well, that the input for sine is an angle, so that negative x represents some angle. Now it does say that negative x is less than 0, so that must be in quadrant 4. So I've drawn the angle in quadrant 4. Okay, and again, remember not to draw things at 45 degrees. So there's some general angle, negative x. And the sine ratio is a length in the unit circle. So what I'm going to do is I'm going to make this circle radius 1. And that makes the length, the vertical length of this, equal to sine negative x. Okay, the sine value represents then the y value of that position. So that length here is going to be sine negative x. And I can treat that as a length now. So I have sine negative x, I have this picture, but the question is asking me for the arc cosine, the inverse cosine. To do inverse cosine, I need to have the horizontal component. I know the horizontal component is going to be whatever sine negative x is. So that vertical length I've drawn now needs to be expressed as a horizontal length in the standard position. So that's going to be, since the y is negative, it's going to go negative along the x to be represented in cos. So we're going to draw it in quadrant 2. And that same triangle, I'm going to try to draw the triangles fairly the same. Okay, that same triangle then is going to be represented like this, where that horizontal length that I've drawn is going to be the same as the length I've drawn for the negative x angle. And since that's the length, I'm just going to say that that length is the same as sine negative x. So the arc cos means I'm trying to find the angle here. So I'm trying to locate the position that gives me this horizontal position of sine negative x. So I need to find that angle position there. So it needs to be in terms of relative to x. So x, that negative x, well, since we're talking about triangle, we're just going to call that x. That angle is going to be this angle in here. Okay, so if you kind of think of translating those two triangles, if I switch the vertical to horizontal, that angle x ends up in that position. And there's a few ways we can do it. We can work out this angle in here. That's going to be 90 minus x. We could also say that this angle here, made from the 90-degree angle, is also angle x, because we can see that those are parallel lines. The two vertical lines are parallel, the y-axis and the angle line next to x. So those two angles must be the same. So to find the standard position of that angle, well, we know that that angle we're going to call theta is going to be 90 degrees plus that little bit extra angle x. So it's going to be 90 degrees plus angle x. So the inverse cosine is that standard position angle that I've just drawn. So the answer to this must be 90 plus x. Okay, and there is the inverse cosine of the sine of negative of angle x.